This function is called the cubic parent function, also sometimes known as an odd power function. The equation for this one is f of x equals x cubed. Now we'll pick some x values to use so that we can figure out what the graph of this one looks like, since x is your independent variable. So since all we're doing with x is cubing it, that means we can choose any value of x we like. So I'm going to use -1, 0, 1, and 2, and then we'll add to it if we need to. If I put -1 in place of x, then this would say y is equal to a -1 cubed. So that means a -1 times a -1 times a -1. So if I multiply a -1 times a -1, I get a +1. Then multiply it by a -1 again, and I would get -1. Now if x is 0, put in 0 in place of x, and I would get y is equal to 0 to the third power. So 0 to the third power means 0 times 0 times 0. So 0 times 0 is 0, times another 0 is still 0. Now if x is 1, if I put in a 1 in place of the x, this would say y is equal to 1 to the third power. So 1 to the third power means 1 times 1 times 1. So 1 times 1 is 1, times another 1 is still 1. Now I've got x is 2. So I put in 2 in place of the x. This would say y is equal to 2 to the third power. That means 2 times 2 times 2. So let's see, 2 times 2 is 4, times 2 again would be 8. I have a few points to work with here. I'm going to go ahead and plot them and see if I can tell what the picture looks like. So if I do -1, -1, that means I start at the origin, I go to the left one and down one. 0, 0, start at the origin, I'd go over none and up none. 1, 1, start at the origin, go to the right one and up one. And 2, 8, so I'd go 2 to the right and 8 up. 1, 2, 3, 4, 5, 6, 7, 8. Kind of falls off the graph, but I can see approximately where it belongs. Now when I graphed those first 3 points, it kind of looked like it was just going to be a line, like we saw before on the linear parent function. But then that fourth point really shot off the page there. So I think I'm going to want to know a little bit more about what's going on this side here to the left of all of the points that I chose. So I'm going to pick an x value that's over there, like -2. I put a -2 in place of x, and this would say -2 times -2 times -2 for the y value. So -2 times -2 would be +4. And then that +4 times the other -2 would give me -8. So -2, -8. So I'd start at the origin, go to the left 2, and then down 8. Again, falls off the graph a little bit, but it's close enough for me to be able to estimate where it belongs. Now I can kind of see the shape of this graph. It kind of looks like it's going to have a little S curve here in the middle. And in fact, that is what it looks like. I'm going to draw it in 2 pieces though, because it's easier for me to make it look pretty. It is going to go on forever because I could continue making the x's larger and put it into this equation, and I would get y values. They just continue getting larger and larger and larger. Same thing on the other side. I could continue making x values that are smaller and smaller and smaller, closer to -infinity, and I would continue getting y values to go along with them that are also closer and closer and closer to -infinity. The domain on this one, since I can choose any x value I want to and put it in here, any number between negative infinity and infinity, and still be able to get a y value to go along with it, that would mean that the domain of this one is any real number. So I'd say x belongs to the set of real numbers. Now when I put in those x values, when I put in a negative x value, I end up with negative y values. When I put in 0, I get 0. When I put in positive x values, I end up with positive y values. And since I can continue going and they keep getting larger to the right and smaller to the left, that means the y's can be any real number as well. So I'd say y belongs to the set of real numbers as well. Now intervals where this one is increasing, decreasing, and constant. To determine those, I have to look at the graph from left to right and see which way I would have to be moving my pen in order to draw the picture. So I'm going to start at the left side, at the first place where I can actually see the curve. As I'm moving my pen to the right, I'd have to also move it up in order to stay on the curve. So that means this is increasing. And it's still increasing here. Still moving upward, so it's still increasing here. And if I continued on, I would have to continue moving my pen upward in order to stay on the curve. So that means this is actually increasing for x values all the way from a negative infinity, as far over here as I could possibly go, to a positive infinity, as far that direction as I could possibly go. So I'd say it's increasing on negative infinity to infinity. Now we just determined that it's going up forever, no matter how far we go, either direction. So that means that it's never decreasing, and it's also never constant. What you need to know about this function is you need to know its name, cubic. You need to know the equation, f of x equals x cubed. You need to know the shape of the graph. You need to know the domain and also the range.